Hello everyone, I am Sanjoy Chandra Mohanto. Our research topic is energy generator mechanical rumble strips. So here is our team member. Now I will talk about the concept of our research. In Bangladesh, we have crowded cities like Dhaka, Chittagong with huge busy roads. But this huge traffic can be our asset. Nowadays, rumble strips are implemented at many places, and while passing over those vehicles waste some of energy. So instead of wasting those energy, we can store and use the energy. The main objective of this research to extract green energy using rumble strips. For this, we will use the potential energy from vehicle and convert it into electrical energy. We have huge amount of roads and high frequency of traffic. So we can utilize rumble strips as a new source of energy. The design concept is basically when a car passes any rumble strips, car speed is reduced and it loses some potential energy. But using the mechanical rumble strip, we can utilize the potential energy that we have been lost earlier. When a car passes over the rumble strips, it will press down a surface about 1 inch and it produces a linear motion, and a mechanical module converts it into a rotational motion. Then it will run generator and that produce electrical energy. Later on, we can store the energy and can invert to use as AC power. Basically, mechanical segment is to convert linear motion into rotational motion. Mechanical segment consists of a rack and 5 gears. This is a two-stage gear train and the total gear ratio is 1:4. The second large gear is unidirectional that rotates the shaft only when the rack moves downward, otherwise it will rotate freely. We have designed a frame with 2-inch steel angle. We have taken 4 steel pipe as a spring holder. Both sides and the bottom of the frame will be supported by a 2 concrete layer. 2 steel beams are taken to support the middle segment of the frame and surface, and we have calculated the beam thickness of 5 mm and length is 80 mm. And done displacement analysis for 10 tons of load and found displacement only 0.031 millimeter. So we have designed the surface that will made of 6 millimeter steel tread plate and done static analysis for 10 tons of load. So after the analysis, we have found displacement for load impact around 0.2 millimeter. That can be considered and found stress not more than the allowable stress of carbon steel. So as you can see, here is our assembled block of rumble strip, and here is the exploded view of our assembled block. So now I will talk about the electrical segment. This is the circuit diagram for one block of rumble strip. The generator will be connected to a boost converter through a rectifier. With a charge controller, the battery will be charged and finally from the battery inverted by inverter then supply the load. So here is the circuit for total system. For total 12 blocks, there will be 12 generators of 500 watt and each of them will connected to with a rectifier and also a boost converter. 3 generators will connect to a charge controller and 4 charge controllers output will be connected to a battery bank. Consists of 6 batteries of 200 ampere hour And finally, one inverter of 3 kilowatt will supply the AC loads. We have developed a prototype for only the middle segment of the main frame. We have used a DC generator of 350 watt, 3000 RPM due to unavailability of expected product. Two sloped wire attached to pass motorbike over the prototype. So here is a short video of prototype testing. So here you can see we measure voltage using oscilloscope. In result analysis, we have tested our prototype for total 205 kg of load. We have tested and collected data for 3 different of loads and 100 ohm, 50 ohm and the third one is 22 ohm. In different speed, we have used an storage oscilloscope to determine the power when the bike passing through. So here we have got the maximum energy for 22 ohm and load is 2.5 watt second. And then we have identified a huge power loss and that occurs due to internal resistance. After considering that, we got maximum output for 22 ohm and is 9 watt second approximately. Also, our shaft speed was 76.3 rpm where the rated speed of the generator was 3000 rpm. So it didn't get the desired power. So also the built mechanical component was too heavy and to rotate the system requires a higher torque. So it increases the power loss. So after completing the research, we find the lack of accurate equipment affects device inferior performance actually. So to solve the issue, we can simply increase the gear ratio from 4:1 to 16:1 to meet the required speed. And this will increase the efficiency close to 90%. So finally, we can say this research has taught us important lessons, emphasizing the need for more research and develop to improve the design, get the required tools, and optimize the device for better performance. So that's all about our work. Thank you, everyone.